Hello my friends, this is the fifth video in our Management of Information series. In this video, we will not introduce something new. We will only show you a different aspect of system development life cycle. For more videos, please visit my Facebook page, Healthcare Quality. In this video, we will talk about Zackman framework. In 1987, John Zackman published a different approach to the elements of system development. Instead of representing the processes as a series of steps, he organized it around the points of view taken by various players. These players included someone who has undertaken to do business in a particular industry, the business people who run the organization, the systems analyst who wants to represent the business in a disciplined form, the designer who applies specific technologies to solve the problems of the business, the builder of the system, and finally, the system itself. Mr. Zackman represents each of these perspectives as a row in his matrix. If the rules are represented by rows in a matrix, the things examined can be represented by columns. Specifically, the columns represent the data manipulated by the organization. What? Its functions and processes. How? Locations where business is conducted. Where? Events that trigger business activities. When? The people and organizations involved. Who? And the motivation and constraints which determine how the business behaves. Why? This is a representation of Zackman framework. We will talk about each of them in the following illustration. As we mentioned, the rows represent the points of view of different players in the system development process, while the columns represent different aspects of the process. The players are: number 1, scope, ballpark point, definition by the enterprise's direction and business purpose. This is an industry view, governmental, concerned with the things that define the nature and purpose of the business. This is necessary to establish the context for any system development effort. Number 2, model of the business, owner's view. This defines in business terms the nature of the business, including its structure, functions, organization, and so forth. Number 3, model of the information system, architect's view. This defines the business described in step 2, but in more rigorous information terms, where row 2 describes business functions, for example, as perceived by the people performing them. Row 3 describes them specifically as transformations of data, where row 2 describes all the things of interest to the enterprise. Row 3 describes those things about which the organization wishes to collect and maintain information, and begins to describe that information. Number 4, technology model, designer's view. This describes how technology may be used to address the information processing needs identified in the previous rows. Here, relational databases are chosen over network ones or vice versa. Kinds of languages are selected and program structures are defined. User interfaces are described and so forth. Number 5, detailed representation, builder's view. This is a view of the program listings, database specifications, networks, and so forth that constitute a particular system. These are all expressed in terms of particular languages. Number 6, functioning system. Finally, a system is implemented and made part of an organization. Now we come to the columns in the Zackman framework that represent different areas of interest for each perspective. The columns describe the dimensions of the system development effort. These are: number 1, data. Each of the rows in this column address the understanding of and dealing with any enterprise data. This begins in row 1 with a list of the things that concern any company in the industry, affecting its direction and purpose. As you pass down through the rows, you move to progressively more rigorous descriptions of the data. Row 2 is a business person's view, and row 3 is a disciplined translation of this, until you get to row 4, where a specific design approach and a specific database management system is specified. Row 5 is the detailed representation of the data on the computer, tables, base, and the like. And row 6 is a working database. We move to the second column, which is function. The rows on the function column describe the processes translating the mission of the enterprise into successively more detailed definitions of its operations. Where row 1 is the list of the kinds of activities the enterprise conduct, row 2 describes these activities in a contiguous model. Row 3 portrays them in terms of data transforming processes described exclusively in terms of the conversion of input data into output data. The technology model in row 4 then converts these data conversion processes into the definition of the program module and how they interact with each other. Pseudocode is produced here. Row 5 then converts these into source and object code. Row 6 is where the code is linked and converted to executable programs. In column number 3, network, which is concerned with the geographical distribution of the enterprise's activities. At the strategic level, row 1, this is simply a listing of the places where the enterprise does business. At row 2, this becomes a more detailed communications chart, describing how the various locations interact with each other. Row 3 produces the architecture for data distribution, itemizing what information is created where and where it is to be used. In row 4, this distribution is translated into the kinds of computer facilities that are required in each location. And in row 5, these facilities requirements are translated into specifications of particular computers, protocols, communications facilities, and the like. Row 6 describes the implementation communications facilities. Column number 4, people. This describes who is involved in the business and in the introduction of new technology. In row 1, model of the people is a simple list of the organizational units and each unit's mission. In row 2, this list is fleshed out into a full organization chart linked to the function column. Here also requirements for security are described in general terms. In row 3, the potential interaction between people and the technology begins to be specified, specifically in terms of who needs what information to do his job. In row 4, the actual interface between each person and technology is designed, including issues of interface graphics, navigation paths, security rules, and presentation style. In row 5, this design is converted into the outward appearance of each program, as well as definitions of access permissions in terms of specific tables and/or columns each user can have access to. In row 6, you have trained people using the new system. Column number 5, time. This describes the effects of time on the enterprise. It's difficult to describe or address this column in isolation from the others, especially column 2. At the strategic row 1 level, this is a description of the business cycle and overall business events. In the detailed model of the business row 2, the time column defines when functions are to happen and under what circumstances. Row 3 defines the business events which cause specific data transformations and entity state changes to take place. In the technology model, row 4, the events become program triggers and messages, and the information processing responses are designed in detail. In row 5, these designs become specific programs. In row 6, business events are correctly responded to by the system. The last column, column number 6, motivation. Mr. Zackman originally described this column. It concerns the translation of business goals and strategies in specific ends and means. This can be expanded to include the entire set of constraints that apply to an enterprise's efforts. In row 1, the enterprise identifies its goals and strategies in general, common language terms. In row 2, these are translated into the specific rules and constraints that apply to an enterprise's operation. In row 3, business rules may be expressed in terms of information that is and is not permitted to exist. These include constraints on the creation of rows in a database as well as on the updating of specific values. In row 4, these business rules will be converted to programs design elements. And in row 5, they will become specific programs. In row 6, business rules are enforced. The major contribution of Zackman framework is its explicit recognition that there is more at work here than functions and data. From the beginning, we should be recognizing the organizational issues. From the beginning, we should be dealing with multiple locations. From the beginning, we should be explicitly concerned with timing, triggers, schedules, and so forth. A change in focus today is the realization that tremendous investment leverages can be obtained by making decisions at as high a row in the Zackman framework as possible. For example, the decision to invest in an information system can cause significantly more savings than lack of productivity at the construction or analysis and design levels. Every feature or function added at the row 1 level to an information system can cause significant investment in its development at all succeeding rows. It is this realization that the enterprise architecture planning level provides the maximum leverages that's driving current trends to define and represent rows 1 and 2 of the Zackman framework for information system architecture. Later, it becomes apparent that rows 1 and 2 and possibly 3 will represent the primary areas of organization innovation and competitive advantage. Rows 4 and 5 will become a mechanism for rapid, reliable, and cost-effective applications implementation based on looking at applications development trends, increasing technological complexity, and the project composition of the application development workforce. This concludes the first group of videos for management of information. In the second group, we will talk about types of information systems and some examples. And in the third group, we will talk about value added by information systems. Thank you.